Okay. Recording.
Yeah, I'll figure out how to, we've got a OneDrive
Okay.
location that you should be able to drag it to.
Okay, so I mean, our status is we've been running it in SMPS mode for quite a bit. We've also so basically with the TSI SMPS next to it. We've also run the two CPCs, our old CPC and our new CPC in parallel and all that, and try to learn the ropes in the process. So far, I mean, maybe Guy can show this very briefly. I mean, this is just from he finished this 5 minutes ago, but this is basically, so the CPC comparison looks great once you put a longer tube on it. So that's, so I think we're happy there. We are still not completely sure about the size distributions. I mean, Guy, can you show
Yeah.
us?
Yeah, I can share it here. This is not the Igor file here. So basically, this is just the CPCs right here with a long tube right here, and this looks really good. Yeah. But then, as Pedro was talking about, this is with the
Maybe
SMPS
put
here.
the non-lock ones away for now and just
Right.
the other two.
So this is the new SMPS with CPC from Brechtel, and then this is TSI, CPC, and SMPS.
And I mean, I think there's a question that yours looks higher resolution and all that, but what is weird is that we are always the numbers with that we get with yours are always a bit lower.
How much lower?
Basically, if you Guy, can you grab the
non-log?
Yeah, the total counts.
Right here.
Yeah.
Yeah.
And take the offset out. So that's integrated counts over the same range.
So you're saying it's about 20% low?
Roughly, yeah. Yes.
What charger are you using?
Pardon?
Are you using the same charger for both systems?
The neutralizer?
Yeah.
Yes, we are.
And which unit is that?
Yours. It's a polonium.
The single strip polonium?
Double.
2 strips.
Okay, so it's the larger one, not the little. Did I sell you the little mini one, or?
No, we have basically 3 of the big ones from you.
Okay.
And furthermore, this is a pretty fresh one. I think the polonium is from April, right, Pedro? We looked.
Yeah, so we got actually a new batch of strips not that long ago. So this should be reasonable. I mean, we were mostly thinking maybe this is some issue with the units. I mean, but in the end, it's so maybe you can explain. So what corrections do you apply in the inversion? So I should also say this is not done with your IPF. This is straight from the reader output. I don't know if there's any difference between the inversion you do in the reader and the inversion you do in the IGO script. Maybe that's.
I think we purposely try to make those identical. Otherwise.
Okay, it makes sense, yeah. But just checking.
The only, I'm not the person that writes that particular software. So, the one thing that I'd want to confirm, about a year ago or a year and a half ago, we actually added the diffusion loss in the DMA.
Okay.
So, but I'm assuming that that got updated in both the Igor and the reader. But you guys should run the. You should
run it on Igor. We just didn't have time, but yeah.
Yeah.
So.
Because yeah, I can ask. Off the top of my head, I can't tell you for sure that they are absolutely the same, but I know that that's some. We don't want it to be different. It just causes a lot of confusion then, right? So.
And so, what do you? How do you do the the multiple charge correction. I mean, I don't see anywhere in the software that you're in a place to enter the D50 for the inlet. Or you don't. I mean, it will obviously not affect this necessarily, but I just to understand.
So we have our own charging model. We don't use the Wiedensolar approximation. We
Okay.
use actually a full charging model. It's been published. It was actually Xerxes, who's the staff scientist here. It was a big part of his PhD at Caltech. So, you know, but the fact that we don't have the cut size is kind of interesting.
I mean, at least the UAV software doesn't have an input for that. So, you know,
what are you running an impactor in front of the charger?
yes, we have the 8009 in front of it.
Yeah.
8009. And so your sample flow to the TSI unit is about what?
So yeah, so we are basically running. We have your saturator flow in front of the DMA, so that we still get 3 and 0.3 for the for those flows. To make sure that the flow in the TSI one is the same, we have basically a bypass on the TSI CPC, so it's also 0.65, because normally that CPC does 0.3.
So you have to apply some kind of dilution or something?
Yeah.
Or?
But basically the TSI one was running 6.5, 0.65, and yours was running 3.35.
Okay. So the total flow through the impactor was about 0.7 then?
Yeah, 0.6. Yes, 0.7. Yeah, pretty much. Yeah.
And I'm sorry, remind me again at the very beginning, you said when you put the two CPCs side by side,
they are identical. Yes.
They're comparing, and the D50 of the TSI CPC is what?
Oh, we didn't. So we didn't. The way that the TSI DMA is set up, we didn't have an impact in front of that one. But again, we are only integrating up to 375. So in the end, that for the counts, it shouldn't matter. But we can repeat that. I mean, it was just yeah.
So I mean, the problem is the multiple charging does propagate down through all the small sizes. If it just kind of keeps having an effect if there are a lot of big particles that are over, that causes overcounting in the equivalent.
I mean, maybe we'll just disable the multiple charge correction on the TSI and see what that does. We haven't gotten there yet, so.
I'm not sure I would do that.
No, you can just do this in post processing, right? Not during acquisition. You can just select when you export it, which way if it applies it or not.
So can you uncover the
Guy, can you go ahead?
So are these raw or processed? What
This is DN log TP in both cases.
Okay, because it says DN raw. Is that something else?
That might just be the nomenclature of Doug's code.
I see.
Where is that?
Right up here in the heading.
Up there, right. But the units on the right are the correct units.
And the color scales are identical, so it's really
So oftentimes you see these sorts of differences getting larger between the integrals when there's a substantial number of sub 40, 30 nanometer particles because of, differences in the diffusion losses, and then the corrections may not be in.
I mean, you see this very brief. I mean, Guy, can you re-enable the offset?
Right here.
Yeah, please. So you see, there's this little spikes there where the TSI is a tiny bit better, and once you you apply the 20% correction, and that's pretty much lines up with the with the particle growth events that you see at the bottom.
Yeah, but one of the things that's interesting is if you see the red spike, the second sort of high concentration event after 6 a.m.,
Yeah.
you see how the divergence is bigger there?
Yes.
That suggests that there may be a small particle dependence in this difference.
Yeah, that's what I meant. That's basically, it lines up with these four things here, right?
So, so that's already 20% corrected. So, to bring our data up to match the red one would take another, whatever, 5 or something percent or whatever that difference is.
Wasn't this wasn't this the test where we ran it through a long length of copper tubing there to account for?
And I don't think we did this for the SMPSs. I mean, what we can obviously do is play with the integrating from channel 3 and 4 instead of from channel 0. So I mean, I think that can be found out exactly where the losses start. I mean, my main concern is understanding the 20%. I think those the small particles, I think we can get a handle on that easily with a bit more testing.
So take the correction off again.
Yeah.
Because I mean, you have this long time right before 6 a.m. where there really aren't a lot of really small particles. So,
And I mean, again, this is not even sampling. This is sampling room air, so there shouldn't be a lot of big particles there to begin with.
So, I mean, technically, if you really want to do a comparison like this, all the upstream sampling train should be as identical as possible between the units. So in theory, all the way down to the impactor, whatever, dryer, impactor, blah, 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 all this stuff really needs to be the same to be able to discount, any just sort of upstream sampling biases. So the diffusion loss differences between the inlets, if there are different flow rates, you have to make an accounting with different tube lengths,
I mean, as with the exception of not having an impactor on the TSI, this was pretty much identical on both sides. But so we can add that and repeat. But that's pretty much, I think, the only difference that we. And again, I mean, we don't need to spend half an hour on this. It was just, I mean, I would say in general, it has worked very well. We are very happy with the signal to noise ratio. Just trying to understand exactly how what things go into the inversion and what to look out for.
No, I mean, it's a standard DMA, TUMI approach.
Okay.
It has the charge correction. It should have the DMA diffusion loss correction. It has the CPC sampling efficiency correction.
Okay.
All the major corrections should be applied. We actually recalculate the matrix for the inversion after each scan. So we use the average pressure and temperature that was measured during the scan to recalculate all of the coefficients in the matrix before we do the inversion for that particular scan. So, we think we're doing a pretty good job.
Okay.
And the folks in Leipzig, they've also got one of these systems, and when they ran it in comparison with their scanning DMA setups, found much better closure than this.
Mhm.
within 5 or 10%.
I mean, we the very first test we did was not on the same inlet, but in the same room, and that one was actually closer, but it was about 10%.
Mhm.
But you could see some, especially in the particle growth events, some delays because one was close to the window, one wasn't. But so yeah. But so in terms of actually the details, so the Eiger software should have an input for the D50.
I'd have to check. I don't know the details of that off the top of my head.
Okay. Because I mean, I'm looking at the reader. I don't see any entry for that. And that brings me to the next question. So, what exactly is what are the units on impactor pressure?
Millibars. Hectopascal. Take your pick.
Okay. And what so we basically would have to convert that on our end to flow. Or
The CPC sample flow that's measured is used as the DMA sample inlet flow.
I understand that, but well, actually, that's a good point. So for our, I mean, not an SMPS mode, but when we are using this in a calibration system, right? We're gonna have 2 liters sheath flow and 0.2 liters CPC flow. And so the thing is that so first of all, is there a way to input a different flow rate in the reader? I don't see one.
How are you going to create a 0.2 liter per minute CPC flow?
Well, we have this, this whole mixing tube extra, loop behind the DMA, basically. And that's the other thing. So basically, the plan was to run to have the impactor basically running at 0.8 to 1 liter per minute or something like that. So basically, to give us a cutoff of 450, 500 nanometers, and then pull most of that after the impactor. Now, of course, it's going to be less because we're going to have the saturator flow there. And then, after the DMA basically provide some extra flow to the CPC so that basically we've only pulled 0.2 liters per minute to the DMA.
Okay,
And so to do that, I mean, we know how much the saturator pulls. We know how much the 2 extra flows are because we have critical orifices and flow meters. So having a real-time estimate of the flow through the impactor would be basically the one variable we are lacking. And then obviously also, being able to put the 0.2 into the software.
I think you're going to need to measure your dilution flow you're adding to the CPC inlet after the DMA.
Yes,
right?
we measure that too, yes.
So if you're measuring that and recording that somewhere, then you have that parameter to use as correcting the actual CPC sample flow because the CPC will measure the total.
Right.
And then in terms of the impactor flow, I mean, you can try to calibrate it versus pressure drop. I mean, that's something we don't normally do because it's not really as high a quality measurement as directly using a laminar flow element. But if that's the best you have, that's something that you could calibrate yourself just as a function of delta P.
Okay.
If that's good enough.
Yes, it'd be an indicator if something went wrong. So you definitely want to have that just as a monitor, right? Very true.
Right.
If something was changing in your flows that have been calibrated.
Okay,
So with respect to entering a different value for the sample flow of the DMA, this is only for mono generation or also for scanning operation?
I think it will be mostly from mono. I mean, I suppose we could, I don't know if there's any benefit in running 3.3 versus 0.36. I mean, you tell me, but to reduce the CPC flow a little bit. But I mean, mostly this is for mono as well. So we can get, we still can get to the high voltages with the lower sheath flow, and we still get decent resolution, right? So that's
right. So for the mono operation, I mean, if you simply know that the way you operate the system is within this flow setup, and you measure that dilution flow that you're adding to the CPC input, then it's just you're
I can calculate
the resolution at that point. Yeah. So, but if you wanted to scan in that configuration, that's a little bit different. Then we'd need some sort of real-time measurement of the actual flow going through the DMA. And I don't know how good the impactor would calibrate out in terms of resolution of sample flow. You guys can tell me.
Right, but I mean, I guess we can decouple that discussion from the impactor, right? I mean, as I said, we can have flow meters on both on the excess flow behind the impactor and on the dilution flow on the CPC. And at that point, as you said, we should have a very accurate measurement of how much we're pulling through the DMA. So not now, but if maybe at some point it might be nice to have that option in the reader to provide that. But yeah.
So one word of caution: the one way we know the CPC will flood,
okay,
is if you try to push air into the inlet. So if you have a dilution setup that let's say it's a mass flow controller with a small pressure.
No, we only do critical orifices from ambient. No, and there's a flow meter behind, but there's no. We know that the flow controllers is that karma. We've tried that. So not with your system, but as well. It's not, yeah.
But how do you use a critical orifice on flow you're adding to the inlet of the CPC? I'm not sure I understand how that would work. You're sucking the dilution flow through.
So the CPC basically has a Y, right? And you're basically just sucking you're sucking some out of the DMA and some out of just from a critical orifice that is at the same pressure. And then you have behind the Y, you have a mixing tube, and then it goes into the CPC.
But then you're not operating the orifice under a critical flow condition. You're just using it as a calibrated restrictor, kind of.
Sure. Yep. Which is why the flow meter is a good idea.
I see. Okay. So and this is mainly just for when you're on the ground and you want to do like ammonium nitrate calibrations.
Correct. Yes. Yeah. Which is in the end, we've been talking a lot about the SMPS operation or the SEMS operation the last month or so, but ultimately this is mostly for the main objective is still to have this as a calibration system on the ground, and the rest is nice extra to have.
And maybe future applications, I guess, if we use it for other things beyond the aircraft. Yeah. So.
Hold on. So where was I? Let me look at my cheat sheet. So, since we are on the subject of the calibrations, so two concerns we had. I mean, basically on the TSI one, we have used in the past, we pretty much ended up replacing all tubing with stainless. Mostly because the AMS that really doesn't like the silicone tubing. You can see the plasticizers very well. And B, also because we sometimes like to put very nasty stuff in there. And so the question was, I mean, so what would you think are the so what would you feel comfortable putting into that DMA in terms of like 200 micrograms of bisulfate would be fine? Would the humidity sensors and all those things like that, or is that you think that would be a problem?
Any polar compound, organic, whatever, is probably going to destroy the response of the humidity sensors.
Okay.
You know, I mean, the DMA internal surfaces are aluminum. There's some, I'm not sure exactly what kind of plastic material we're using, but I could find that out. So if you have any material that's aggressively, that chemically is aggressive towards aluminum, or anything like polycarbonate, or the laminarizer, I think is also a it's like a very fine, like a plastic mesh material. You'll probably destroy, you'll probably destroy those.
Okay.
So, I mean, I don't have a list of specific compounds that, I can tell you, don't do this, don't do that.
No, I understand that. I mean, I guess then the question would be, I mean, it seems like the one at the entrance of the DMA is fairly critical. So maybe, it would be an idea if you quote us a spare, because I wouldn't be surprised if that one at some point doesn't like us anymore.
But getting rid of all the black conductive tubing
is a project.
It's a little project, but I mean, I would agree. One thing you could do, perhaps, unless you just completely want to get rid of the black tubing, is to cut off the black tubes, for example, where they attach to the polydisperse inlet fittings. Cut them off short, and then use them as seals over some 1/8 OD 90 thou ID stainless steel tubing that you can then run as your inlet. So you'll have a very small millimeter section exposed, but that would be a lot easier than actually removing. You could also unscrew the fittings that have the barbs on them. They're, I think, just 1032 holes.
Okay.
We use Beswick fittings with the O-rings in them.
Okay.
You can probably buy fittings that are compression, so you can put 1/8 OD metal tubing directly into the compression fittings.
Yeah, or quarter inch. Yeah. No, we'll look into that. So yeah.
The flow is really low, so but yeah, whatever works for you is fine.
No,
And
so
then,
I think I think especially like the other ones we can look into it, but I think both the front of the DMA and also obviously the pump line on the CPC will have to replace it, just so to make it more sturdy for the aircraft installation. So so I think that's since we're talking about installation, I mean, just to double check so I think that at this point, the only pump that we have from you is the one in the DMA, right? The Sheathstone pump. That one is brushless, correct? Because they were yelling at us again about that.
I'm not sure it is, actually.
Okay.
You need to have a brushless pump?
Yes, unfortunately.
Okay, I didn't know that.
I mean, they're gonna do a spark test in the lab, so we'll see. But if we need to replace that pump, we should look into that soon.
When are you guys flying again?
We are integrating early December,
Okay,
but we are not. The first actual flight is gonna be on January 20th.
Okay.
So we have some time to fix things, if you know.
I'm sorry, you said you're integrating in December?
Yeah, second week of December, yes.
So the pump thing actually, getting pumps these days can be a challenge.
Mm-hmm.
So maybe the brushless ones aren't as hard. I don't know.
Okay.
But
I mean, I guess the main thing would be to find out if there's a drop-in replacement, right? Because otherwise it gets pretty complicated.
okay.
Yeah, on that subject, I mean, we are having a long discussion with these guys about spares because, of course, they have planned poorly, and they want to basically strap everything to the plane, which of course doesn't have enough capacity. Blah 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 blah. But so for 2 months, I mean, what spares would you suggest should we have on hand from your experience? I mean, we discussed the RH sensor, but that's obviously just one thing.
Mm-hmm. Hold on a second here.
Mm-hmm.
We have a maintenance kit that has, pretty sure it has all the pumps, but of course they're not brushless as far as I know.
And we wouldn't need the ones for the CPC anyway, right? So
that's true. Hold on a second.
Yeah.
So, usually the first thing is the pumps. I mean, the pumps are the things that, they usually last a couple of years at least, but these are small, relatively, I mean, not totally inexpensive, but they're, $400 a piece or something.
Mm-hmm. All right.
They're not meant to last for 10 years or something like that.
Right.
Where they're built.
At the same time, if we replace it, well, I mean, we can get two anyway when we identify the part number, but yeah, okay, that's good to know. Okay, so the other question we had is, so we're trying to kind of figure out how we're gonna log the CPC counts when we are in mono disperse mode.
Yeah.
So the first option, I guess, is you have this readings file that the UAV reader puts out. That would probably work, but I mean, there are two problems. One is the file itself, I think, has a bug because you are recording at 10 milliseconds, but it's not putting fractional seconds into the timestamp. So when you try to import it into IGO, it looks a bit funny.
I think what you might be seeing is we've cheated. We're not going to write it. I mean, if you're I think it writes out at 5 hertz maximum. Instead of writing 5 rows per second, we write the 200 millisecond values at the end of the row. If that's what you're referring to. I don't know if that's what you're referring to or not. So it's kind of a kludge, but it's a way that we worked around in terms of maintaining, compatibility with older data import software that we have with customers. So if you,
I understand, but I think maybe something is not set up properly on our end, but it is not 5 hertz. It's 100, and these files are huge. Like, for one day we get like half a gigabyte. So maybe it's something that is set wrongly in the firmware. Let me, Guy, can you stop sharing for a second?
So this is when you're trying to save data, you still are connected to the mSEMS.
Correct.
And you're looking at the MCPC readings file.
Correct, yes. And that's what I'm trying to do right now. 1 second. So here. So this is the file we took yesterday, I believe. Let me move this, and you can see, here's your header, and here's your 000. And let's look at the line numbers since we have them. So this is 34. And 1 second starts at 134. So there are 100 values there per second.
Yeah, looks like a bug. What version of the UAV reader software do you have?
830. I actually have it here in TeamViewer, so wait a second. So this is basically what we are doing right now. So I'm actually, yeah, you can see it up there. It's actually running at the moment, so.
Yeah, that's some kind of bug.
Um,
100 hertz is probably a little more time resolution than we need.
right. But in
If
the
I
end,
could put out 100 hertz CPC data, I would.
yeah,
I would,
it's steep
I
a
would be
bit,
a little bit wealthier than I
overkill.
am now.
Yeah.
Yeah. It's also, at some point it also becomes a problem with, this space if you're making these huge files, right? So
For sure.
Yeah, no, that's obviously not something got set wrong, either
Right.
the reader or it's the write to that file is being called inadvertently multiple times in the software when it shouldn't be.
Right.
So in fact, how many bins do you have set right now in your
I just started it actually just before the meeting, so it's probably at the 120, which is kind of the default, but we were running at maybe just a quick detour briefly. So one thing that we were trying to do when running the comparisons was to run your software at the same data rate as the TSI. But you don't really have a time grid, right? And so we noticed so for the scans we were doing, it seems that in general, after pressing the start button, it takes about 16 seconds to start, and then there's about 3 seconds overhead per scan. Does that sound reasonable? Those numbers reasonable to you? And how do those change if we change the settings?
16 seconds sounds a little bit long. What do you have your delay time set to right now?
We didn't actually touch that yet, so that's another problem possibly in the comparisons. But since it looked actually the distribution looked very, very on close, we still need to put PSLs in, but it's 1.1 right now.
Yeah, so as you know, between each scan, you have to allow physically enough time for the air to flush through the system.
Okay.
Otherwise, you don't know where you're starting.
Mm-hmm.
So you do a scan and then you wait roughly 3 to 4 delay times, which in your case should only be about 4 seconds.
Okay.
And then you start the new scan.
Okay.
And so there's always going to be dead time between the scans,
Mhm.
but not 16 seconds. I mean,
No,
it
no,
may
no,
be-
no. The 16 seconds is different. I think the 16 seconds is, but it sort of matters for us because we were trying to start them at the same time, since there was no time grid. The 16 seconds is basically when you go from stopped to scan, and I think that's basically the time it takes the sheath flow to to become stable enough for the software to decide the scan. So. And yeah, I mean, I guess there's not much we can do about that, but yeah,
yeah, I think in
the
general,
first couple of times we tried it, it was always 16 seconds off because we started them both at at the full minute, so it was kind of
yeah, we let users design their scans completely differently than TSI does.
Yeah, I see that.
We don't have fixed bin structures. We let you optimize the size range and the number of bins that you want for whatever the question is you're trying to answer. We think that's just a more powerful way of making the measurement. So, but it does it creates idiosyncrasies between, exactly setting both the systems up the same way, because you actually can't, I think.
But I mean, it's so what you are saying, and I think that's also what I saw in the data, is that I mean, I think the starting delay, I think we just have to get a bit better at that. Or maybe it's better to just what we haven't tried yet is to go from mono to scanning. Maybe that's faster. But it does sound like the inter scan delay is going to be extremely consistent, and then and I mean, my impression is that it's pretty much on a grid regardless of if you enforce it or not, which the TSI software wouldn't be, just because it's an old clutch. But anyway, so that's fine.
Well, and for that delay, is your concern, Pedro, because you like to start the AMS logging at exactly the same time?
I'm more thinking now, actually, if we run this as a
about that?
SMP as a SMS on the plane, that we kind of report in reproducible time intervals, kind of thing. So just to make that a bit simpler. Okay, so let me go back.
I mean, I think normally what people do is you don't care exactly what's going on at the very t equals 0. You need to have at least a reasonably stable enough aerosol that if the two systems are measuring over enough time and their timestamps are right and match each other, well, then they're measuring the same aerosol at the time that they're making their measurements. If you need to interpolate between size distributions, I mean, you could do that, but as long as your size distribution is reasonably stable, then they should match.
Actually, let's go. Wait a second. On that note, Guy, you want to show there's really not that much to show, but in any case, can you show the SMPS comparison again? Let me stop sharing. And I'm not finding my mouse right now. Okay. So I should stop sharing, which is here for some reason. Okay. So one thing that we're a bit confused about, but in the end, the test was not as good as we thought it would be. I'm just trying to move the participants here. So after we run this comparison, right? So pretty much at the end of this, and let me grab my. So we grabbed, this is the right one. So we basically took 60 nanometers, which is here, something like that, and there. So we put basically both SMPSs at 60, which, as I said, it was kind of a mistake because we were trying to be quick, and probably 50 would have been better. So this might just be the whole reason why this is not looking. But the really strange thing was that in the end, the counts on, so this was really just mono mode. So the counts on your CPC were 30% higher than on the
These two, I
TSI
think
one.
they were.
So let me,
think-
sorry, let me get rid of the annotation.
I think they were these two right here.
Not sure where my annotation went, but I cannot delete it.
So you were size selecting room air,
Yes.
like
So
And
the
statically.
idea was to basically be on that peak of the,
Mhm.
of the icon mode and pretty much see, without any scanning, how well the two are compared.
And I think this is the new one here from Brechtel, and then this is the TSI one.
Correct, yes, yeah.
Yeah, so as far as I know from the flows you described, our data should be 17% higher because the transfer function width is that much broader.
Right.
So I don't know what the ratio is, but
I apologize, but I have absolutely no idea how I can get rid of my annotation. It's just went away and I cannot delete them.
Maybe if I go back here, does this help?
No, I think it's a really, maybe Zoom is confused because I'm recording and it doesn't let me do that.
Hmm.
No, anyway, okay. Sorry. So yeah, so basically you said that the transmission correction is 17% there.
well, I think earlier you said you ran the mini-SEMS at a 0.35 sample flow and a 3-liter sheath.
Correct, yes.
So the ratio of the sample to sheath flow is what sets the width of the transfer function of the DMA, you
Okay.
know? So basically, if you make the mobility window broader,
Yeah.
then you're going to transmit more particles. But the TSI was run at 0.65, 6.5. So it's running at a 10-to-1 sheath to sample ratio. So its window is 17% narrower.
Okay. Mhm.
Makes
But
sense.
that's still not quite enough, I think. I mean, it's basically 28 versus 20 or so.
Uh-huh. Yeah, that's 40% difference. You've corrected for whatever your dilution was on the CPC and all that sort of stuff.
Yeah. We didn't have any dilution on either of them. So
Yes.
I mean, they're completely different DMAs. So I know.
I know. No, this was just, since since we're seeing the 20% offset in the integrated ones, how it would look like basically in single scan. And yeah.
It's kind of ironic that we're higher. I
Right.
mean, if anything, you'd expect us to be lower. So
Mhm.
why it's higher? I mean, it's 17%, I think we can explain, but the other 20%,
Mhm.
that's funny. There's the 20% again.
But in the opposite direction.
Mm-hmm. So TSI has all built-in diffusion loss corrections as well, or what are they doing in their processing?
Doug is the expert there, but I think the SMPS has the dilution so for the in SMPS mode definitely has the diffusion correction.
In the SMPS, but if you're just running them straight to the CPC, you're just measuring it
nothing
with the
there, no.
CPC. I don't think there's anything applied there. So this is kind of raw in that sense, right?
Yes, correct. Yeah. So if you are applying a diffusion correction there, but I mean at 50 nanometers, it shouldn't be that much, really.
And both of them are not doing the charge correction here, right?
Sorry?
Both of them are not doing charge correction in each
Correct.
system.
Yes. Yeah.
A few percent of this is the difference in polarity. You guys
Right. I was going to say that that's not symmetric, right? Plus and minus.
No, but it's only about a 3% effect.
Oh,
So
okay. Is it
not-
small here?
not super big, but it's there.
Okay. So yeah, I mean, maybe stop sharing. So back to and I think now it went away, so it's good. Mm,
Um,
Yes.
I grabbed my eraser and went over your thing and it got rid of it. I
Oh, I
see
see. Okay,
Zoom
good.
up, but
I
Zoom
also-
just updated their annotation tools to this very different looking bar. So
I also did
News to
the
me.
clear annotations thing, and it went
Okay.
away. So maybe we did it at the same time.
yeah,
we don't
yeah,
know.
okay,
Actually,
maybe it did. Yeah, yeah.
In
Something
any
in
case,
Zoom
so
got upgraded too. I don't know.
back to the how to
Yeah.
how to record the CPC counts, because in the end for calibrations that's really the most important number, and that has to be exactly time synced with the AMS measurements. So we have discussed basically getting it from the file, but that's not that helpful obviously during operation. So if I summarize the email thread from the last 2 days, and correct me if I'm wrong, I think we've tried it once, but just to be clear, we can keep the SMPS and the SEMS and the CPC connected at all times. We can have both USBs going to both instruments, and then we just have to basically switch between the USB and serial mode on the CPC depending on the UAV reader mode that we want. That's
I don't know if that's going to work. I mean, I don't know because I've never tried it, not because I know it won't work. Normally if you want to do mono generation, you pick mono size right there.
right. But the problem is if I do that, as I said, I don't get a time series, and so you can never, you know how nebulizers are and impactors and all those things. So it's nice to see the last 2 or 3 minutes to know, what it's doing. So yeah. Which then, so I mean, we can try that. I think if we have time at the end of this, I can even do it while you're still around. But so that would be that. Then the third option, I guess, for us would be to use the serial and try to import it somewhere, right? So this should basically have the same format as a readings file if I do that.
Roughly, yes. But now the challenge is this. So let's see, hold on a second. This is the external serial port on the mini PC.
Okay.
And unless you have the mixing CPC directly connected to the reader, you can't access the CPC data directly. You'd have to get it through the mSEMS, which might be possible.
So sorry. So basically, if we are running in this mode as we are right now, right? So does this number get exported?
It's being saved to a file. I don't know that it's being exported anywhere. I could check.
Okay.
You,
And since we try to be thorough, so the last way I thought we might be able to do this is by teeing a BNC into your raw counts line. The question there would be what resolution of a counter would we need if we wanted to count on the DTLs that the CPC produces?
yeah, it's kind of above my pay grade.
Okay.
But I could find out.
Okay. Now, mostly because we have a bunch of NI devices on our end that all have counters, and so one of them might actually have the capability to count that. And
I
then,
mean, pretty much all the standard National Instruments digital counters, as far as I understand, seem to be perfectly fine.
okay.
But there probably is a minimum, sort of a minimum technical capability that's required that I can find that for you.
Okay.
But I would hope that there might be a much simpler solution through this.
Sure.
I think that there ought to be a way. You want the mini-SEMS running and saving data because you want to know with time what size you picked.
Right.
But what you're saying is you like a real-time view of the concentration so that you can make decisions about changing the atomizer or whatever, that sort of thing.
Yeah, so it's two things. One is you want to know that it's stable, and the other thing is that for depending on the calibration, you need to actually hit a very specific number. And again, since this is ammonium nitrate, that is slightly temperature dependent and so on. So we typically, even when we are really skilled at it, it takes us often like 3 or 4 minutes to really dial in where we want to be. And we always, like, our particle generation system always has a dilution line to adjust those counts and so on. So that's mostly what it is about.
So go back to the mSEMS tab.
Yes.
So if this raw concentration value down here was actually displaying, that's not really enough. You really need like a timeline plot or something.
So if you had a third tab here that shows me that number over the last 10 minutes, I would be so happy. But yeah, whatever can be done. Okay. Getting towards the end of the question, so maybe we'll be almost on time.
Also, those are the things, Pedro, I guess, where the, sometimes the impactor gets clogged and starts tanking, and then you want to,
Right. Although, I mean, that's
clean it out and
actually the other
keep
thing.
moving or whatever.
That's so you have. So one thing I wasn't quite clear. I mean, you have here this.
That's the
Okay.
trigger threshold.
So we should probably set that much higher. Much lower, sorry, yeah, man, but yeah.
Well, I mean, that's not clogged. That's still,
Right.
it's up to you. You can set it to whatever you want. But normally there's a red light that comes on. If the measured impactor differential pressure reaches that trigger level, then in theory, there's supposed to be a red light somewhere that alerts you that, hey, you've got to do something. I'm not seeing that light here.
I think it's here. Or not? No?
Oh, yeah. See impactor status.
Yes, exactly. Yeah. No, I mean, that's very helpful. And but let's say with the TSI systems, what we have found is that, I mean, what they give you is so basically if the inlet pressure drops more than 10%, you basically should abort mission. So we have to basically calibrate what that is, on your impactor, but that's basically a pretty good number.
Yeah, so you can load up the impactor all you want and then measure what the differential pressure is and decide, how big of a pile of particles on the impaction surface is still acceptable to you, and then set the threshold to that number.
Okay. On that subject, so Guy was trying to calculate the 50 of the impactor. So I guess we need two numbers. We need the diameter of the going in, and then basically how much room it has to turn around. And I think the manual only has has one that is the jet diameter, which we are not sure which of the two numbers it actually refers to. So if you could clarify, that would be very appreciated.
Yeah, all the critical dimensions in a standard round jet impactor scale from the jet diameter. So we should have just explained that in the manual where, I think you've got the hole size, the jet diameter, and then I think the spacing is twice that. And I think the impaction surface is 3 times that.
The diameter of the impaction plate.
Yeah.
Okay.
I mean, let me just, before I say something wrong, let me just look at this real quick.
Have we talked about the time zone issue as well?
No, that was next on the.
So the 8008 should have a 22 thou jet diameter.
Mhm.
And then the distance between the outlet of the jet to the impaction plate is 44 thou.
Okay.
And then the diameter of the impaction plate is 66 thousandths of an inch.
Okay,
Excellent. And then yeah, so one thing we were having issues with is very stupid. So for some reason we don't seem to be able to adjust the time zone on this thing. I mean, I should say we did run your script so that it doesn't, you know, do Windows updates and all that. So maybe that's related to that.
Hmm.
I tried to change the time zone before.
But basically
we
it
did
doesn't
it.
let you.
Maybe you have to be logged in as administrator or something, and maybe we don't set that permission for the generic login.
Okay.
That's strange. I've never had anybody bring that up. Do you want it to automatically do this, or?
I think we would be probably happy to basically all the aircraft instruments on UTC. So if we can change it once to UTC, that's all we need.
And when you click the change manually button, it doesn't work?
You can change the day, you can change that, but you cannot change the time zone.
Oh, the time zone.
And you know, so I installed the NPT server from Mindberg so that it, you know, syncs all the time, and that is working. But of course, that's, you know, for that it needs to know the right time zone. So that was a problem.
Yeah.
All right. Well, again, that's above my pay grade. I don't know.
No, sure.
Change time zone in Windows. I mean, this is a Windows problem.
And another very minor thing was so on this MCPC, so the next to the COM port, there is this switch that says program data. I mean, it's I didn't find anything in the manual describing it. I guess we just leave it wherever it is, but
Well, it's actually good for you to know exactly what that switch does. So that switch is only used if you have to update the firmware.
okay, so okay.
So it should always be in the data position.
Okay.
But when you have to program it, we might actually be sending you a firmware update because you have the kind of vacuum only setup, right?
Correct, yes.
So we recently realized that there's still an interlock in the firmware that you're running in your CPC that basically if the sample flow and the saturator flows get too different from each other, the software decides that it's not going to fill with butanol because it's worried that there's some weird pressure instability and that there's going to be flooding if we let liquid in.
Okay.
Well, the problem is that in your configuration where you want to fly at quite high altitudes, we purposely want the saturator flow relative to the sample flow to go up at lower pressure because it's more and more difficult to activate and grow the particles as you go to lower pressures. Well, that interlock, we left it in the software. So it means that it's not going to let butanol in.
Okay.
So we're testing a version of firmware now that adjusts the criterion so that it allows.
Okay.
So
I mean, to clarify, so what we have heard from NASA is that the maximum, so for the actual science, not for the transit, but for the science flights, the maximum height is going to be 10,000 feet. So it's not going to be, you know,
that's extreme. Not bad. Okay.
So
yeah. I'm sorry, I kind of went off on a digression there. You asked a question at the beginning of that I think I'm not sure I addressed.
No, it was the switch. So that I think we
right,
yeah.
okay.
So we understood that. No, yeah, then the last thing I guess is one is you said at AAAR that you have a design for so is it correct? So basically the CPC itself has maybe like 10 mils of butanol in it, or is that more or less the size of the reservoir? 10, 12?
It's probably a little bit more than that. I think it holds about 12 mils, 12 or 13 mils in a wick.
Okay.
So it's like a sponge in there.
Mm-hmm.
And then there's like 1 or 2 mils of free butanol that's sitting up on a window that we
Okay.
have a level sensor that's remotely detecting the presence of that film.
Okay.
And when the unit starts using enough butanol that the wick is pulling up that free liquid, the level sensor detects that there's no more free liquid there, and that's when it tells the software to open the solenoid valve.
Okay.
So we have a very different approach to handling butanol than most CPCs. We only want to let in a couple mils at a time because we don't want to create this bathtub of butanol that, you know,
That
is just
floods the thing all the time.
around.
Yes, I hear you.
So at any given time, the UAV version of the CPC you have has a slightly larger saturator size compared to the benchtop unit. It should have, you know, roughly on the order of 15 mils, and that's what gives you the roughly 7 hours of endurance, because we use about 2 mils an hour under standard temperature conditions, you know, between fills. So that means you don't have to leave the bottle connected all the time if you don't want to. But
I think we want to.
Yeah, no, I mean, if you can, and if the aircraft folks are fine with that, then, you know, then that's the better way to go, as long as they're not doing super, you know, well, even if they're doing crazy maneuvers. We recently, no, actually, if you do if your maneuvers are too steep, you know, all the butanol will flow to one side and the level sensor will think there's no butanol, and then it'll just open the valve and let liquid in.
I mean, we can I mean, the plane does depending on the pilot, they will do 54-degree banks, but they normally announce those, so we can switch off the CPC before that.
Well, you need to disconnect the bottle. Well, if you shut off the power, yeah, that'll do the same thing, but it's kind of inconvenient.
Okay. No, but I mean, the concern is basically, I think that the problem is that the refilling butanol is a huge deal there. And so they all, you know, you always need to get a crew member with a fire extinguisher and so on. So I think having a reservoir that lasts for about a week is probably, you know, the way to go. Otherwise, we're gonna get very unpopular there.
So I wonder if you added a little like Teflon ball valve into the line from the bottle. I wonder if you could cheat but I just hate the idea of somebody having to walk over there every time they announce a bank. I mean,
I mean, we have everything. You know, we'll have your we'll have the UAV computer on. Now, I mean, let's say switching it off would not be a big deal, but yes, I mean, I think the idea with the valve is good. And I mean, I've asked them exactly what kind of container they would like to have for having 100 mils of butanol, but they haven't gotten back to me, so I have to actually ping them again. But you know, I mean, in the past, like in a previous mission, we had like acetonitrile in a glass bottle with you know, with some metal reinforcement around it, and we had like 100 mils in there, and they didn't complain. But you know, so something like that probably would work.
So it burns at about 2 mils an hour at 20 C.
Right.
So you got to be careful, you know, every 5 degrees C increase in cabin temperature, that burn rate's going to go up. I'm not even sure how much, you know, might go to 3 mils an hour at 25, and then maybe it goes to 3.5, whatever. You know, the hotter you make it, the more butanol you're just leaving out of the exhaust.
So I mean that okay. That's the last. That brings us to the last point. So, despite the fact that this is a winter deployment, the only real winter we're gonna see is in Korea.
Mhm.
Everything else is tropical locations. And since that plane has a pretty shitty AC system, and we sit in the wrong spot, surrounded by mass spectrometers, I mean, 33 degrees is probably a pretty good estimate of the cabin temperature around us.
Mhm.
On a, if you're doing boundary layer runs all the time, which I think, as we discussed in a previous talk, is going to be a bit hard on the saturator, right?
I mean, 33 is okay. I mean, it's warmer than we like, but I mean, we run it in the hot box here for multiple days at 38.
Okay.
So again, I think the two biggest issues, one is the condenser inside the CPC has a really hard time keeping the temperature we'd really like.
Okay.
20C is the magic number, but what happens is, basically as you heat everything up, the condenser temp is going to go up. Maybe it goes to say 25. So that means, all the delta T's are kept the same. So
Okay.
the optics is run 10 degrees warmer than that, and the saturators run 25 degrees warmer than the condenser. So the
Right.
saturator's at 50C. So it can kind of turn into a positive feedback situation where if you're already hot and then all these heaters are heating more, well, then the unit gets warmer, and then
Right.
it's yada yada. So having some cooling air blowing actively over the CPC is super important. That will help a huge amount to let, it's just going to come to some new equilibrium point based on whatever your ambient temperature is.
Right. So
But
based
you will use more butanol. So, you kind of want to count on that in terms of estimating how big your reservoir has got to be.
So I think you suggest in the manual, because my inclination would be to get a 120 millimeter 12-volt fan and have it basically blow on it. I guess from the back would be best then for something like that.
Yeah, that's fine. You can either do it from the back or right over the top, directly over the top.
Yeah, that's a bit harder to mount. So that's why I thought that the back has the advantage. Then we kind of take the ale air that is probably the coolest at that point. So
yeah.
Would the DMA also benefit from extra cooling, or?
I don't think it really cares.
Okay.
As far as we can tell, the thing it's pretty bomb-proof in terms of the heating.
Okay. I mean, the only other concern we had was, NASA is not NSF, so it's always very hard to tell if how happy they are with open electronics. So right now we are not planning any cases around it, but they might eject do that. So if that happens, we'll talk. But
yeah, so I think the thing to just keep in mind is what we were just talking about with the cooling.
Correct. Yeah.
Enclosure's got to be designed in a way that the air is going to really be able to do what it needs to do.
I mean, based on previous things, what might have to happen in the end is that not even a case, but they will probably demand some kind of, that basically there's some sheet metal on top, so that nobody can, put their hands in there.
Yeah, that makes sense.
And that probably wouldn't impede cooling that much, but TBD.
Okay.
I don't know. I think you haven't really designed a housing for these things, right? I mean, that's kind of customer responsibility, correct?
Yeah, we don't have any off-the-shelf solution for that, because we generally are selling into applications like yours where pretty much whatever we had designed wasn't going to fit.
Okay. All right. I mean, I think that was what I had. If anybody else wants to chime in.
One thing, getting back to the comparison with the TSI, if you guys really want to do this, I would set up a generator that's really generating a mode, you know, at 100, 150 nanometers and has very few particles in the diffusion dominated size range below 50. You know, and dilute the hell out of it and dry it so that the concentrations are reasonable, and then split it, mix it, split it, neutralize it, split it.
Mm.
If you really want to get down to the nitty gritty, you know, if you want to get anything within 5 or 10%, you're going to have to make sure you have a really stable input.
We'll get to that, and we'll have actually, you know, since for other reasons, our calibration system has a 10-liter buffer volume. So basically, you know, put the nebulized output in there, and then sample from there. And I think that should give you a fairly good comparison.
And I think you need to process the raw mSEMS data with the Igor script.
Okay, that's better.
Yeah, I think you're going to get better quality data from that, I think, because of, you know, the horsepower that's on board in the ARM chip architecture, the mSEMS is, I mean, it can run the basic inversion, but it's not, doesn't have the numerical depth or quality that Igor does when we process the raw data.
Okay. So we'll do that and run it again and see what we get.
Yeah, I'm curious to see if you see any difference if you just grab the raw data from the study you already did.
Yep.
I mean, maybe it'll be the same.
We'll do that. Okay, so that was very helpful. Thank you. And thanks for staying overtime.
Yeah.
But just to maybe in terms of things we might be in touch over the next couple of weeks, I guess the most important would be, I guess, the pump, correct?
Yeah.
Since there might be supply issues. And I guess maybe, yes, right.
Timestamp. I think Fred was writing down notes, it looked like, but yeah. UTC. Well, the timestamp bug and then
the
UTC.
timestamp is definitely a bit annoying,
Yeah,
yes.
yeah. A lot of data.
Yeah, I don't know what the hell's going on with that. And, you know, we can't prevent Windows updates anymore. So unless you keep that thing off the web all the time, you
it will be. It will be. Basically, so, you know, so we have a mini network on our rack, and that is not connected to the internet. So as soon as it's really in final flag configuration, that thing will never be on the real internet. And so we'll be fine.
So just know that if you do update Windows, there are these Windows batch files in the support software folder.
Yeah, we use those.
Yeah, you need to run those every time Windows updates, because we never know what the hell Windows resets.
Right.
And when it gets into the USB port settings, they start turning off ports to save power, and that immediately interferes with the communication of the instruments.
Right.
And we know that happens because people call us and complain about it, and we basically.
And basically, so
you want the kit, Pedro, but the pump's kind of a separate. The most important
I mean, I guess the kit, you said it was mostly pumps, right? So basically, so we have we discussed the pump, the brushless pump, and I guess the other thing was maybe if you can quote us the, you know, that one element you have in front of the DMA inlet element. I guess we should maybe get a bunch of those just in case.
Yeah. Yeah, no, I've got the RH and temperature sensor, the brushless pump. I'll put together a list of spares. I mean, there may be things that I'll tell you to get that aren't necessarily in the kit, just so not stuck.
I mean, a lot of it we have ourselves, like, you know, the blue filters we have, they are part of our spares as well. So, you know.
I'll talk to the engineers about fixing that bug in the reader with the CPC data. I'm not exactly sure where that's coming from.
Right.
We'll get your firmware updated for the vacuum only.
And yeah, then whatever. Sorry, yeah, go ahead.
You'd asked about a digital counter to read the CPC pulses, if you guys were going to set that up yourselves. And then I'll ask the software guys about whether or not we can add a CPC count visualization in mono mode so that you can actually watch the.
I mean, the other question would be, is it, well, but if you could somehow get that number from the little controller, but I guess that would be way too complicated as well, but it doesn't matter.
Yeah.
Mhm.
So those are all the things I have on my list.
No, I think that sounds correct.
And
Okay.
just out of curiosity, when we are pulling 0.2 liter from CPC in our configuration, does that mess up some correction you does in your system, or that different sample flow through DMA need to be updated in your correction equations eventually, or?
Yeah, it's true. If, you know, the CPC is going to measure the dilution flow you're adding plus the 0.2 liters that was drawn through the DMA. So the mSEMS software by itself, when it's doing the online inversion, is going to assume whatever, the 0.36 liter sample flow that the CPC measured is what actually went through the DMA, when that's physically not what happened, right? Only the 0.2 liters would have been pulled through. So it is possible in that case that the diffusion loss correction would be an overestimate because the flow rate would be lower. But if you're really only doing this in mono mode, then I'm not sure how important it really is.
Okay.
Because if we're gonna give you a readout of the concentrations, well, those are the real concentrations that you care about.
Right.
The size is the size. So
Yeah, that's a concern if you want to do it in a size distribution mode.
yeah, if you
Right.
want to do scanning, then I think the option, if you want to do it scanning, I believe what we've built into the Igor post-processing software is if you need to make some changes in the way that the system was configured, we actually allow you to tweak some of the settings that are used that go into the inversion. So this sample flow thing might be one of them. I don't know exactly what all those little boxes are that we say, okay, you can reset this. The reason we do that is because sometimes customers set things to one configuration, but the unit was actually run with a different configuration. So, you need to be able to go back to the raw data and reprocess it in the, with the configuration that was physically implemented, not what somebody incorrectly.
One very last question, because I wasn't quite clear from our emails what you ended up doing. So, is there a universal limit for the high voltage, or are there different limits depending on pressure, or what does the firmware do right now? I mean, can you always go to 5 kV, or what? How?
No, the maximum that I think we let you go to is 4.5 kV.
Okay.
And that maximum decreases with pressure.
Okay.
It has to, because the studies we did in the lab, we could start to see particle generation. For example, at the lowest pressure we sampled, which I don't remember how low that was, but we started seeing small numbers of particles being generated right in around 3 kV.
Okay.
So the threshold set to 2.6, I think at again, I don't remember what that
Okay. No, just understand,
we tend to run our TSI below 8,000 in Boulder here.
Right.
But up to 10 at sea level. So
yeah,
semi-empirical, but
yeah. So the one thing I will say, be careful if you need to run it at high humidity. I mean, I ran it here at the lab in the mid 80s. Things looked okay, but I could tell, if I really tried to push it 90%, low 90s, I could start to see, a few particles, not like big bursts, but you don't want to arc the DMA. You're just going to potentially damage it. So we were a little bit conservative in setting some of these levels, but not so much that it should significantly impact your, the size you can really reach.
I mean, that's the one concern I think is basically, this thing when you so you're in the tropics and the plane has been a bit higher and now goes back into the marine boundary layer, then sometimes you are able to actually get like 90% inlet RH. But I think outside of that, typically the RAM heating will take care of it. So.
But you have a dryer, right? I mean, you're drying the sample flow to the DMA, aren't you?
Yeah, I mean, we are not, well.
for mono calibrations for sure, right?
for the calibrations, we have Nafion dryers everywhere. So basically, you know, the calibrations run at 30% RH. And as a matter of fact, Guy has been testing your Nafion in vacuum mode, and it works great. So in case, you know, anybody asks you, it works very nicely in vacuum mode.
Okay.
So
Surprised it holds. What level of vacuum have you been able to hold inside the printed?
so what we need is about 100 torr or so, right? That gives you a factor of 10 in well, in Boulder, a factor of 8 in, you know, absolute humidity, and a factor of 8 also in flow speed. So yeah.
But if you don't, I mean, I highly recommend you guys dry in flight if you're going to run this thing during flights. You're going to risk sparking it if
Okay.
you hit high humidity.
Oh, yeah. Well,
Right, cold plane in the boundary layer, in
I
hot
mean,
boundary layer.
we'll think about it. I mean, so far, I mean, for the AMS, we never dry because it just strips all the, you know, semi-volatiles, and it's just it's not good to have a dryer on the AMS line. But we can put one behind it. Yes, that's not a problem.
Okay.
Okay.
All right.
Thank you so much.
Right.
Yeah, no
Thank
problem.
you.
And, you know, if you have any more questions about the intercomparison, just let me know. And I'm just
Okay.
curious to see if you reprocess the mini-SEMS data, if you do see any
Yeah.
difference.
Okay.
But other than that, I'll get back to you with all this other stuff within the next few days.
Okay. Thank you so
Okay.
much.
Yeah, good to
All
see
right.
you.
Thank you.
Have a good
Bye-bye.
weekend. Bye.